Hello everybody. I want to show you a trick that can help you reduce the amount of work you need for partial fraction decomposition problems. It will not work 100% on every problem, meaning if you get an answer to these, the answer will be right, but you may not always get an answer. You may still have to do some solving a system of equations, but it can reduce the number of variables that you have to work with in that system. So let's take a look at this and see what we've got. So I've got a partial fraction problem right here. As always, I set up the fractions the way I should set them up, and then I cross multiply. So I multiply by t plus 4, t minus 1, and t minus 2 on both sides. And on the right side, of course, that cancels out my fraction. So all I have is the numerator. And on the left side, when I multiply by the a over t plus 4, the t plus 4s will cancel. So that gives me an a times t minus 1 times t minus 2. And for the b's, the t minus 1 cancels. So that leaves a t plus 4 times a t minus 2. And on the c, the t minus 2 cancels, so that leaves me with a t plus 4, t minus 1. So there's no difference at this point. But here's where the magic actually happens. This equation is supposed to be true no matter what value of t I have. So I'm going to very cleverly choose some t values to plug into this equation and see what I get. In particular, I want to make these guys be equal to 0. So I'm going to plug t equals 1 into both sides. When I do that on the left, I've got negative 8 times 1 squared minus 11 times 1 plus 24. And that works out to a negative 8 minus 11 plus 24. That works out to a 5. On the right side, I've got a times, I'm plugging in t equals 1, so 1 minus 1 is 0. Oh, that goes to a 0. On the b term, b, I'm plugging in t equals 1. That gives me 1 plus 4. And I'm plugging in t equals 1, that gives me 1 minus 2. And then the c gives me 1 plus 4 times 0, and that one goes away too. So look what I've got here. 5 equals b times 5 times negative 1. b equals negative 1. I'm just going to write that up there so I don't lose it. Pretty cool, huh? All right, let's continue on. Let's plug in t equals minus 4 and see what happens. So I'm looking for things that make those factors equal to 0. See how nice it is when I keep it factored. This is going to give me a negative 8 times 16 minus 11 times negative 4 plus 24. And that works out to be negative 8 times 16 plus 44 plus 24. That gives me a negative 60. And over on the right-hand side, I have t times minus 4 minus 1 times minus 4 minus 2 plus, we already know our b term is minus 1, minus 4 plus 4, oh, that goes to 0, so I'm just going to put a 0 there, and c times negative 4 plus 4, oh, that one goes to 0 too. So here's my equation, negative 60 equals negative 5 times negative 6 is 30, that's an a there, 30a, so a equals minus 2. Okay, I'm going to erase the board. Now let's look at our third term. Whoop, I erased it too much. Let's write this again. Negative 8t squared minus 11t plus 24 equals a times t minus 1 times t minus 2 plus b times t plus 4 times t minus 2 plus c times t plus 4 times t minus 1. And we already know that b equals negative 1, so I'm just going to put a negative 1 there, if I can get this erased. And I know that a equals negative 2, so I'm going to put a negative 2 there. And let's see what we can do. We've already plugged in 1, and we've already plugged in minus 4. So let's go ahead and plug in, whoops, that's the one I already did. Let's plug in t equals 2. That's the one we haven't done yet. So negative 8 times 2 squared minus 11 times 2 plus 24 equals negative 2 times negative 2 minus 1 times negative 2. Oh, I should be plugging in positive 2 2 minus 1 times 2 minus 2. Let me check that right side. Positive 2 squared, positive 2. I'm good there. So that one goes away to 0. The b term has a t minus 2 in it, so it goes away to 0. And so that leaves us with c times 2 plus 4 times 2 minus 1. So the left side gives me negative 8 times 4 minus 22 plus 24 gives me a negative 30. And the right gives me a 6 times 1. So c equals minus 5. And let's check this. Move that over so I can see what I wrote. A is minus 2. B is, I think, minus 1 we decided, and C was minus 5. I won't do the integral. Oh, I copied the wrong thing. B is minus 1. And voila, it works. So just wanted to show you that little trick. Now, when will this not work? If you have irreducible quadratics on the bottom, so say I had maybe 4 times t squared plus 1, and let's put a repeated root in here, t minus 2 squared. When I set this up, you know, for my linear, I'm going to have a constant over t minus 2, but because it's repeated, I'm going to need a t minus 2 squared, and then the linear term has a ct plus d over it, t squared plus 4. Now when I cross multiply, I'll multiply by my t minus 1 squared times, t minus 2 squared, and my t squared plus 4. That, of course, cancels everything on the left-hand side. On the right-hand side, that leaves me an a times t minus 2 times t squared plus 4, and a b times t squared plus 4, and a ct plus d times t minus 2 squared. Okay. If I plug in a 2, I can still eliminate a variable. On the right-hand side, that just stays a 4. This, when I plug in 2, becomes a 0. On the second term, when I plug in a 2, it becomes an 8b. And on the third term, when I plug in a 2, that gives me a 0. So I know that b equals a half. But now I can't go any farther because there's nothing that'll make that quadratic be equal to 0. Okay, so I can't do anything more than this. So I know that b equals a half. I still have to go back to my first technique, and I have to solve the system to find out what a and b are, or a and c and d are. But now instead of 4 variables in my system, I have 3. So this can give you problems. When the bottoms are irreducible quadratics, it will give you problems because there's nothing that'll make that equal to 0. Also, when you have repeated roots, notice with repeated roots, I have 2 terms here, so I have 2 variables. I was only able to solve for 1. It still helps you out. It reduces our system by 1 variable when we solve our system at the end. But it doesn't give you the complete answer. But it's still worth doing. So I hope this is helpful, and take care. I'll see you on the final. Bye-bye.